Welcome to the Explainer. Today, we're going to crack open the code that basically runs the modern world. It's the language behind almost every app, website, and service you use every single day. We're talking about SQL.
So let's start with a simple question. Ever stop to think about how your favorite streaming service just knows exactly where you paused a show, or how an e-commerce site keeps your cart full for days? The secret behind all of that magic is a database. And the special language that lets us talk to it, that's SQL.
Now, the most common kind of database out there is a relational database. And really, the best way to picture it is as this perfectly organized digital library. Your data isn't just thrown in a big, messy pile. No, it's meticulously sorted into tables. Tables with neat rows and columns, just like books on clearly labeled shelves. Okay, so if we have this amazing library, how do we communicate with it? Well, we use a special universal language, SQL. It stands for Structured Query Language. And it's the standardized way we talk to these databases to build their structure, to manage the information inside, and, most importantly, to ask for exactly what we need. You might be thinking this is some brand new, cutting-edge tech, right? Well, actually, SQL has been the trusted backbone of the data world for about half a century. So let's do a quick flyby of its journey, from a research project to a global standard. It all started back in the 1970s, inside an IBM research lab. It was originally called SQL, but the real turning point, the thing that made it a powerhouse, happened in the mid-80s. When it became an official standard, first by ANSI and then ISO, it was a huge deal. It was a promise to developers that the SQL they wrote would work pretty much anywhere. And that right there cemented its role as the world's universal language for data. All right, so how does this thing actually work? I know, a whole programming language can sound intimidating, but the good news is we can break down almost everything SQL does into three really simple ideas, using our library analogy as a guide.
Think of it like this. First, you have to actually build the library. You design the shelves, and you label all the sections. Second, you have to manage the books. You know, putting new books on the shelves, updating their info, or maybe taking some away. And third, the really fun part, you get to ask the librarian to find the exact piece of information you're looking for.
So that first step, building the structure, is handled by something called Data Definition Language, or DDL. These are the commands that are basically the blueprints for your database. Before you can store a single piece of information, you have to use DDL to define the tables and columns where it's all going to live. Let's look at a classic DDL command. Create table. It's super readable. We're literally telling the database, hey, create a table for me and call it employee. Then we tell it what columns we need, a name and an email, which are varchar. That's just a fancy word for text. And adobe for a date. And boom. Just like that, we've built our first digital shelf. It's empty, but it's ready.
Okay, once our shelves are built, it's time to actually fill them up. And for that, we turn to Data Manipulation Language, or DML. These are the commands for doing the real work, adding, changing, and deleting the data itself. This is all about managing the books in our library.
The insert into command, it does exactly what it sounds like, right? With this one simple line, we're adding a new employee. We just tell the database to insert into our employee table. We specify which columns, name, and email, and then we provide the values we want to put in there. It's incredibly intuitive. And that brings us to the third and honestly the most powerful part of SQL. This is the part you'll use constantly. It's asking for information with Data Query Language, or DQL. This is the whole reason we bother organizing everything so perfectly, so that we can ask questions and get answers instantly. So to see this in action, let's use this simple employee table. We've got a few people here, each with an ID, name, department, and salary. Now, let's say your boss comes over and asks a very specific question. Hey, can you get me a list of everyone on the sales team and what we're paying them?
So, how do we translate that question into SQL? We use the most famous command of all, select. In plain English, what this query is saying is, select the name and salary columns from the employee table, but only where the department column is equal to sales. And just like that, the database filters through everything and gives us back just John and Sam.
That's the power of a query.
Okay, so this language is from the 1970s. In the world of tech, that's practically ancient. So why on earth is it more important today than it's ever been? Let's dig into why SQL is still the absolute bedrock of the data world.
SQL's staying power really comes down to this incredible mix of features. It is wicked fast at finding data. Its standards mean it's universal. It's got serious built-in security. It can scale from a tiny personal project all the way up to a massive global system. But maybe the coolest part is that it's a declarative language. You just tell it what you want. You don't have to tell it how to get it. The database figures out the best way to do that for you. That's a game changer.
On top of all that, SQL databases are built to be rock solid and reliable. They follow a strict set of rules called the ACID principles. Now, we don't need to get lost in the weeds here, but what it means for you and me is that for really critical stuff, think about a bank transfer or an e-commerce checkout, SQL guarantees that your data is always correct, always consistent, and never gets corrupted.
Of course, technology never sits still. A while back, a new kind of database started popping up to handle different kinds of data problems. And that leads us to one of the biggest conversations in data today: SQL versus its younger cousin, NoSQL. So what's the difference, really? Well, it mostly boils down to structure and scale. SQL databases love that rigid table-based structure we've been talking about, which is absolutely perfect for things that have to be consistent, like financial data. NoSQL databases are way more flexible, which is great for messy, semi-structured stuff like social media posts. And when it comes to getting bigger, SQL usually scales up by getting a more powerful server, while NoSQL scales out by adding more servers. At the end of the day, they're just different tools for different jobs. So if we're going to sum it all up, it really comes down to this. We can collect these enormous mountains of raw data, but honestly, that data is pretty useless on its own. SQL is the bridge. It's what connects that raw data to the meaningful, actionable insights that actually drive decisions in business, science, and tech.
And I'll just leave you with this one last thought. We're always hearing that data is the new oil. Well, if that's true, just imagine what you could discover, what you could create, what you could build once you learn the language that actually drills for it. Thanks for joining the Explain